So one has common fields. Hello, can you hear me? Hello. If you can hear me, hello. Yes, I can see 7 people have joined. 7 people, I can see 10. 10 people have joined. Yeah. I can see 11 people. Okay. Can you guys hear me? Please, if you can hear me, you let me know so that we can proceed. If you can hear me, let me know. If you can hear me, let me know. Hello, I can see 13 people. 15 people. Okay. Somebody say we can hear you. So without wasting time, we'll start because we can't keep on waiting for people. We say we're going to start by 8:30, and it's after 8:30 we're behind schedule. So I'm going to start with units and measurements. Units and measurements. So it is good for us to start from the beginning where we started and get familiar with those concepts. Units are very, very important in physics. As we know, we have what we call the fundamental um, quantities and derived quantities. Generally, we know that physical quantities are those quantities that can be measured. And we have the fundamental quantities, and we also have the derived quantities. So just like we learned in the class, if you cannot convert from one unit to another, physics becomes so difficult because this is the beginning. So we mentioned the fundamental unit as length, measure mass, time, current, temperature, amount of substance. So, and we need to know units, the unit of length, meters, the unit of mass is kilogram, unit of time is seconds, current is ampere, and so on. So, but this is not the emphasis. This is not what we're interested in. What we're interested in is, can we convert from one unit to another? Like I said, for you to convert, please, if I'm talking and you can call my attention by sending a chat. Just if there's anything you want me to do, you can send me a chat, and then I will go back to it, please. So just like I said, if we are to convert from one unit to another, what you need to ask yourself is, first of all, you have to know the relationship between that unit and the other. For example, you have to convert from centimeters to meters. The big question is, what is the relationship between centimeters and meters? We know that 1 meter is equivalent to 100 centimeters. And if you are converting from a small to a big unit, what do? You divide. So if I'm converting 2 cm to meter, I simply divide 2 by 100, because that is the relationship between meters and centimeters. Because I'm dividing because I'm converting from a small to a big unit, from centimeters to meters. So I'll simply divide 2 by 100 and I get my answer, meters. The same way I can convert from meters to centimeters. In this case, we have established a relationship, but in this case, I'm converting, or you are converting from a big to a small unit. So you need to multiply. So these are the basic things a student should have as his or her own finger tips. So the conversion is not a problem now. The same thing with if you are talking about mass, converting from grams to kilogram, converting from kilogram to gram, converting from milligrams to kilogram, and so on. But first of all, you need to, okay, somebody say I need to be audible. So like I said, converting from in terms of mass, grams to kg, or a kg to grams, what is the relationship? That is what you need to ask yourself first. You must establish that relationship between gram and kilogram. And we know that 1,000 grams is equivalent to 1 kg. So if you are converting from grams to kg, definitely you are moving from converting from a small to a big unit. So you are going to divide. So let's not dwell on this, but this is the starting point. You need to get um, familiar with these concepts. You need to understand them. But somebody is saying, I can't hear you. Please let me know what is let me get your response. Can you hear me now? Is it better? Is it better now? Is it better now? Let me know you. Let me get your response. If it is better. So that is about the conversion. And then we'll talk about the SI units, that is the fundamental units, and we also have the derived units. Fundamental units, derived unit. Now, what do you mean by fundamental units? And what do you mean by fundamental quantities? Because a question will come in. The following is not a fundamental quantity. And then they will give options. The following is not. So you need to get familiar with this. When you talk about the fundamental quantities. You talk about the mass, length, is that right? Time. And then somebody will give you an option, will give you options, and then they'll bring you something like velocity. Velocity is not a fundamental quantity. Power is not a fundamental quantity. Work is not a fundamental quantity. Energy is not a fundamental quantity. So if options are given, if you are conversant with this, just tick your answer and then you move on. So fundamental quantities, derived quantities. Derived quantity depends on fundamental quantities. For example, if you are talking about maybe derived quantity, something like velocity. Velocity is displacement all over time. Is that right? Velocity is displacement, the rate of change of displacement. Displacement all over time. So it means that velocity is depending on displacement and time. But when you talk about mass, mass is mass. It doesn't depend on anything. And that is what makes it a fundamental quantity. Derived quantities are those quantities that depend on other parameters. That is the fundamental quantities. Like if we talk about acceleration, velocity over time. Acceleration depends on velocity at time. Is that right? And that is a derived quantity. We also have what we call the derived units, SI units. The unit of mass is kilogram. The unit of velocity is meters per second. These are derived units. Derived quantities, derived units. They depend on fundamental units or fundamental quantities. You also need to get these concepts very clearly. So, like I always say, the exam, you need to be very careful because the options, the examiners will always want to confuse you. The examiners will always want to confuse. The answers are always very close. So if you're not careful, you will you will not make it. So I believe by now you'll be able to start your revision and start doing. If you have any problem, let's know it down because we don't have time again. We don't have time again. So the next few weeks you'll be going into the exams. So you need to take this very, very seriously. So when you talk about dimensions, this is another area that students find it difficult. What is dimension? The fundamental quantity dimension rely solely on the fundamental quantities, the basic fundamental quantities, length, mass, time, length, mass, time. And then the dimension of length is L, the dimension of mass is M, and time is T. These are the basic fundamental quantities: length, mass, time. And the dimension of mass is M, dimension of length is L, the dimension of time is T. So, like I said before, for you to determine the dimension of a quantity is either you know the formula or the unit. It's either you know, there are two basic things you must know, either the formula or the units. For example, if you are talking about dimension of area, what is the formula for area? Length times breadth. And what is the unit for area? Meter square. Length is in meters, breadth is in meters. So meters times meters is meter square. All right. And what is the dimension of length? Is L. So it means that the dimension of L is L square. The dimension of L is L square. Is that right? So what is the dimension of velocity? Velocity is displacement all over time. As a matter of fact, it's a derived quantity. So when you're talking about displacement, displacement is length. Displacement distance traveled in a specified direction. So if displacement is L and the dimension of time is T, it means we're talking about L over T. That is the dimension of velocity, L over T, which we can write as L T raised to power minus 1. Please, if you are not getting, if you want to call my attention, just send a chat so that I can go back to it. If there's anything that is, but I believe you should have something like pen and paper where you jot down some of the things. Even on WhatsApp, you can ask me, you can send a voice note and so on, so that we can tackle these things where you are having confusion. So please, let me know where you are having issues. It seems many people are not aware, or they don't know how to connect to this live. We just have 21 people here of that kind of crowd. Okay, it's all right. So just like I was saying, dimensions, the following is a dimension of density. It could be a question: A this, B this, C this. What is density? Density is mass per unit volume, and that is where I'm coming from. For you to know the dimension, if you that particular quantity, if you don't know the formula or the units, there's no way you can determine the dimension of that. Somebody is talking about the network. Well, we don't, don't know what to do. Somebody is asking, what are derived quantities? What are derived quantities? Like I said, derived quantities are those quantities that depend on the quantities from um, fundamental quantities. For example, let's start from the fundamental quantity. We mentioned the basic fundamental quantities: length, we are taking notes, mass, time. These quantities, they have their units, and those units are called fundamental units or SI units, System International. They are standard units. So a quantity like velocity, the definition of velocity is displacement over time. So displacement depends on two parameters. Velocity depends on two parameters, displacement and time, displacement over time. So those two parameters are those things that define the velocity, and they depend on other parameters. So for example, velocity is displacement over time, and the unit of velocity is meters per second. That's a derived unit. The unit of mass is kilogram. The unit of time is second. The unit of length is meters. They don't depend, they are just there. So if you are talking about area, area is length times breadth, and the unit is meter square. If you are talking about acceleration, meters per second square. These are all derived units. Acceleration is a derived quantity. Meters per second square is derived units. I hope it's making sense. And somebody also asks, okay, what the dimension of velocity? Like I said before, we have the basic fundamental quantities, length, mass, time. And the dimension of length is L, capital L. The dimension of mass is capital M, and the dimension of time is capital T. So if you are talking about the dimension of velocity, there are two things you need to know: the formula for velocity or the unit for velocity. And the formula for velocity is displacement all over time. Displacement is measured in length. Time is measured in seconds. So the dimension of length is L. The dimension of time is T. So that becomes L all over capital T. Capital L all over capital T, which is equal to L T raised to power minus 1. I hope it's making sense. So that is the dimension of velocity. So I was talking about a question will be put like this: what is the dimension of density? First of all, what is density? Density is mass all over volume. Density is mass per unit volume, or mass over volume. So what is the dimension of mass and what is the dimension of volume? You know, volume is length times breadth times height. So it means the dimension of volume is L raised to power 3. So since the formula for density is mass all over volume, mass is capital M, volume is L cubed. So the dimension of density becomes M L raised to power minus 3. So somebody asked, what is the dimension of pressure? What is pressure? What is pressure? Pressure is a force per unit area. And what is force? That of area is understood. But if you are talking about force per unit area is pressure. Is that right? And what is force? Mass times acceleration. Is that right? Acceleration, what is the dimension of acceleration? Acceleration is meters per second square. Are you jotting down? acceleration is meters per second square. That is L all over T raised to power 2. So by the time you get the dimension of force, mass, which is capital M, L, T raised to power minus 2, that is force. All over area is L raised to power 2. That becomes the dimension of pressure. I hope it's making sense. So any quantity that you want to get the dimension, you must have an idea of the formula. You must have an idea of the formula. For example, somebody say, what is the dimension of walk? Walk is force times distance. What is the dimension of force? What is the dimension of distance? These are the things that you will be familiar with. So dimension, and we also stated the importance of dimension. The importance of dimension. Dimension can help us to derive an equation. Two, dimension can also help us to check how correct an equation is or a formula is. And we did some examples in the class about these things. So some of these videos that are on the platform, they are not just there for you, it's for you to make use of them. Those videos were carefully selected and they are very, very useful. I don't know whether any of you can make use of vernier caliper or micrometer screw gauge. Let me know on the chat box. Can you use Sorry, there was a power outage. So, can you use um, vernier caliper or do you know how to read it? Can you use micrometer screw gauge? Okay, somebody say we don't know. But those things are meant, they're supposed to use them in the lab. They're supposed to teach you in the laboratory. So I don't know why they have not. A question can come up and they will draw a micrometer screw gauge or a vernier caliper for you to read it. It's a possible question. So if such question comes, you can't skip them. I made a video on how you can use your micrometer, screw gauge, or vernier caliper. Go back and watch those. These are practical things. So if I'm around in the school, I will make efforts to show you how somebody say the issue is which one exactly used to take the reading. You know, the micrometer screw gauge, you can use it to take something like the diameter of a wire, this small wire. Then if you have something like a bottle, the mouth of the bottle, this bottle, the can you drink water from. If you want to measure the diameter, you cannot start taking the ruler to measure the diameter of that bottle or the beaker. You can use a vernier caliper. So these are the things, they are under measurements. So for something like a tiny wire, you cannot start taking a ruler to measure it. Micrometer screw gauge takes care of that. Vernier caliper takes care of the internal diameter of such materials. And the books, you have your textbook, those things are there. You taught them in the class, and I don't know how you have not paid attention to such this thing. So please make effort. If you cannot read micrometer screw gauge, if you cannot read vernier caliper, let me know. Even on the platform, on the WhatsApp, I can I can explain more on that. So these are the instruments that you can use. Some people are still struggling to join this thing. I don't know why people are finding it difficult to in this modern. I'm receiving a lot of chats on the platform. Okay, this one say, I swear I can't even see anything now. It's still loading. It could be network. So let's continue. So that is about the micrometer screw gauge. We can do that. But let's look at go back and study dimensions. Dimensions. I've seen a lot of questions on dimensions. And like I said, if if you cannot know the formula or the unit of that quantity, life will become so difficult for you. And there's something I want us to. Okay, somebody's asked here. Um, the issue is which one exactly, but usually has two reading. Yes, it's what we call the main scale and the vernier scale. The main scale and the vernier scale. So by the time you read the main scale, you add it up with the vernier scale. So that is it. Both the micrometer screw gauge and the the vernier caliper, they have these scales, the main scale and the vernier scale. So by the time you read the main scale, you also add it with the vernier scale, and that will give you the final answer. So I wanted to say something about this examination. you guys need to develop some level of confidence. And what gives you confidence in an examination is your level of preparation. If you prepare very well, you have that confidence and you go into the exam with a lot of confidence. But most of the time, when I come to the class, I don't see that level of preparation. You need to, that's the reason why I started this revision, because by the time they say it's revision week, you can only see us in the class just once, and the revision is over. And we can't do that revision for just one class. It won't be effective. So please start now. And if there's any issue, if there's any problem that you cannot uh, attend to, let me know on the platform so that I can make effort to do such a explanation. Please, you can ask your questions in the comment section so that we can attend to them. We have done briefly the units, talk about the fundamental units, the fundamental quantities, the derived quantities, the derived units. We will talk about how to do the conversion from a small to a big, from big to small. If you are converting, you need to know the relationship and you ask yourself this question: am I converting from a big to a small unit, or a small to a big unit? If it is from small to big, you divide. From big to small, you multiply by that relationship. We have talked about this. And if and only if you pay attention to this, life will not be difficult for you at all. Life will not be difficult. Ask your questions. Let's try and round up. Ask your questions in the comment, the chat box, so that we can round up, so that you can do other things. I also have other things to attend to this night. Ask yourself, okay, we I was talking about time management. You need to practice past questions. I was expecting that somebody will bring a past question here and ask some, so that we can, by the time we are practicing and we are doing past questions, it becomes easier for us. So you need to revise, look out for past questions, and the ones you cannot solve or that are proven to be stubborn, you let me know, so that we'll, we'll do justice to them. So this revision, for those that are interested, we'll be doing it from time to time, maybe by Tuesday or Wednesday, but I'll tell you on the platform. We'll schedule another one. We will look at vectors and scalars, and then the ones that you feel, those areas that you have questions, you bring them up, and we'll be able to answer them. Okay, somebody is asking here, what importance of dimensions? I've said that dimension can be used to derive and the formula. Like in the class, we use dimension to derive the formula for calculating the period. T equal to 2 pi square root of L all over G. We derive that in the class, is it not? T equal to the 2 pi square root of L all over G. We solve that problem. That is one of the uses of dimension. It can be used to derive a formula. It can as well used to check how correct that formula is. So these are the uses. And somebody also asks, how many dimensionless quantities do we have? How many dimensionless quantities do we have? We cannot count them now. There are so many. And another person asks, sir, how many questions should we be expecting and the time limit in the exam? Usually, sometimes 40 questions, and sometimes it could be 50, could be 60. So, but you shouldn't be jittery about the number of questions. You shouldn't be jittery about the number of questions. Your concern should be that once you get into the hall, scan through. If it is 40 questions, then the time given to you, if it is 20 minutes or 30 minutes, from there, you now time yourself. On a particular question, how many minutes am I supposed to spend? And that will guide you through the exams. That is what we call time management. Don't spend so much time on a particular question. Do not spend so much time on a particular question. If it's a question that you don't know, you leave it, move to the next one. By the time you come back, if there's still time, you can attend to all the other ones. Don't spend because you want to solve that particular. No. If you have timed yourself, I'm not supposed to spend more than 30 seconds or 45 seconds on a particular uh, uh, question. By the time you spend that kind of distance, you move to the next one, whether you answer it or not. Answer the ones you know that you are comfortable with them first before you can come back. And somebody say, can we get areas of concentration? I've given you areas of concentration. I'm supposed to talk about measurements, units and measurements. I've sent that in on the platform. Units and measurements, scalars and vectors. That's number 2. Number 3, concept of motion. Concepts of motion. Number 4, momentum. Number 5, circular motion. Number 6, rotational motion of rigid bodies. Number 7, work, energy and power. Number 8, gravitation. That is where we'll stop. They are there in your textbook. So number 1 to chapter 1 to 8, that is where we will stop. So these are the areas you concentrate. It's not everything in that your textbook that you. And another person asks a question here. Can we get areas of concentration? I've answered the answers. For someone For some of us that have never seen anyone using the vernier caliper, you have not seen anyone using the vernier caliper. Don't worry. Um, if you want to see this, you can during the practical session, you can approach the person in charge of your physics practical to at least show you what is vernier caliper. They are there in the laboratory. What is a micrometer screw gauge? And someone saying, okay, and they say, how can we go about it? Okay, that is the same game ball. Then another person, D33, difference between displacement time graph and velocity time graph. Okay, displacement time graph. When you talk about displacement time graph, it's a very good question. Displacement time graph, you are plotting displacement against time. And displacement over time is velocity. Is that right? Displacement time graph, it means displacement is on the y-axis, time is plotted on the x-axis. Displacement time graph. And what you are trying to describe there is velocity. When the graph is straight, a straight line graph, we can talk about uniform velocity. And when it's a curve, you talk about non-uniform velocity. Then he said that what of the velocity time graph? You are plotting velocity against time. Velocity against time, and what you are trying to describe is acceleration. Velocity time graph is about acceleration. Displacement time graph is about velocity. So these are the two different things. These are the two different things. Just a minute. So displacement time graph, I hope you got the difference. Difference between displacement time graph and velocity time graph. So velocity time graph describes acceleration, while displacement time graph describes velocity. So if you have more questions, you bring them up, and then we'll be able to round up this class. So please get familiar with those concepts. Practice calculations. Physics is all about calculations. Those topics we have treated from the beginning, from chapter 1 to chapter 8. We have not treated 7 and 8, but we have covered up to chapter 6. That was the last Thursday, rotational motion of a rigid body, and we did circular motion. All these topics, they have videos that you can search and watch them at your own time. And each of these videos has calculations. So it's not left for you to look at them and then clear your doubts. So I think if there's no more questions, we can round it up, go back home, look at units, measurements, Get familiar with fundamental quantities. Get familiar with fundamental units. Get familiar with derived quantities, derived units, how to convert from one unit to another. Talk about dimensions, how to determine the dimension of physical quantities. And then from there, you are good to go. If there's no any other question, we can end the class and schedule it for another day. Good evening, all.